Welcome everyone. In this video, we're going to work out this midterm 1 for Math 195, that is Precalculus. This test covers sections 1.1 to 2.4. No electronic devices are allowed as you're working through the problems. So make sure to follow the instructions. Also, you will find the PDF version of the test in the description box, so make sure to do the test on your own before you check into the solutions. Let's go ahead and start. We're going to call this our solutions. So let's go ahead and start with number 1. Perform the indicated operations. So for this particular example, there are multiple ways to do it. You can choose whichever way you prefer. I'm going to go ahead and distribute the 2/3 first. So if you distribute the 2/3 to all of these, you will have 2/3 times 6 minus 2/3 times 3/2. And there is a 1/2 outside. And now we can simplify these right here. So I can simplify the 6 and the 3. So that leaves me with the 2 here. So 2 times 2, that gives me 4. Minus, now for this term right here, we can also simplify before we multiply them. 3 and 3 cancels, 2 and 2 cancel. That leaves you with the 1. And we still got a 1/2. So just carry it over. Now you can combine them further. 4 and -1, that's 3 plus 1/2. And here you want to put them in common denominator. So write this as over 1, multiply this by 2/2. So that leaves you with the 6 plus 1/2. And our final answer here would be 7/2. And it is already simplified, so you're free to leave it right here. Number 2, we're going to simplify this by using the laws of exponents. So we know that if we have a fraction like this raised to a negative exponent, you are free to distribute the exponents, or you can just reciprocate them, make the negative exponents positive. So I can also write this to the positive power, but I reciprocate my fraction, so that'd be 2ab squared over a to the 4th. Now I can go ahead and distribute the exponent 3 to every term inside the parentheses. So 2 gets a power of 3, a gets a power of 3, and then b squared gets a power of 3, so that's b to the 6th power, because you multiply the exponents. And then a to the 4 in the denominator gets a power of 3, multiply 4 times 3, the a to the 12. And now here we can simplify it further. So a to the power of 3, that's just 2 times 2 times 2, which is 8. So we got 8. A to the 3rd, now here we can actually apply another laws of exponents. We can subtract them. So you will do a to the 3rd minus a to the 12. So that will be a to the -9. And then b, well, b is just b to the 6. So we can keep it like that. Now your goal is to always eliminate negative exponents. So we're going to drop this on the bottom. So our final answer would be 8b to the 6 over a to the 9th. So that will be our final answer with positive exponents. Number 3, another example of laws of exponents. So here we have 32 to the power of -2/5. So again, turn the exponent into a positive exponent. So I'm going to write 1/32 to the power of 2/5. Now you can write this as a radical because it's fractional exponents. We got 1/5 root of 32 to the 2nd power, just like that. Or you can also write this as 1/5 root of 32 square, just like that. So either of these are fine. Of course, one notation is easier to simplify than the other. So here, this is easier to evaluate than to find 32 square. Since you're not allowed to use a calculator, you want to see which way is best. So I'm going to go ahead and evaluate 5th root of 32. So this gives me 2. So this is 1/2. And then I square that number, which is 1/4. So you see how easily I got to that answer with the doing 32 square and then taking 5th root of that. So again, whichever way you prefer, this will be our final answer. And for the next problem, we're going to factor. So it's a quadratic. We're going to open up 2 parentheses like that. So you look for, now since the coefficient of x squared is 1, you're going to look for two numbers to multiply to give you -3, adds up to -2. So we know the numbers are -3 and +1. So I will write x here and x here, then x -3 and x +1. And then if you redistribute, you'll see that it gives you the initial problem. So we're going to go ahead and claim this as our factored form of this. Number 5, we're just going to go ahead and expand and simplify. So we're going to go ahead and distribute the 2 here. So that gives us 4x plus 6. And for the second parenthesis, we distribute this -1 out. So every term, so that gives us -x² plus 5x minus 4. And now you combine like terms. So let's start with the highest power. This one, it doesn't have any like terms. So we're going to go ahead and just rewrite that. The next term we see is x. So you have a 4x here and a 5x here. So you add them up, you get 9x. The next like term we have is the constant 6 and -4. You add them up, you get +2. So there you have it. This is how you expand and combine like terms. So that's our final answer for 5. For number 6, another problem we're going to expand. So our final answer do not contain any parentheses. So when you have something like this to a power, that just means you have that same factor 2 times because the power is 2. So you're just going to rewrite 3x minus 5, 3x minus 5. And then we distribute. So you do 3x times 3x, that's going to give you 9x squared. 3x times -5, that's -15x. Then we go to the -5 to the tx, the 3x, that's negative another 15x, and then -5 times -5, +25. And then again, you combine like terms. So as you can see, this doesn't have any like terms, so we just rewrite 9x squared. And then these are like terms, so you can combine their coefficients. -15 plus -15, that's -30x. 25 also doesn't have a like term, so we just rewrite. So as you can see, our answer contains no parentheses. So this will be the end of this problem. Number 7, we're going to factor. Now it looks like this one has x cubed, this one has x. So you can pull out their GCF. And also in terms of number, the first one has 3 and the second one has 27. 27 can be written as multiple of 3. So I pull out a 3 and an x, and then we just rewrite. So 3x times what gives me this term? Well, it has to be x squared because x squared times 3x will be 3x cubed. Minus, and then 3 times 9 is 27. And then I don't need any x because we already have that in the front. So that will be the inside the parentheses. Now again, this is factorable. So we continue factoring. X squared minus 9, that's a difference of 2 perfect squares. So you got 3x from before. And difference of 2 perfect squares factor as x plus 3, x minus 3 in this problem. So remember, if you have a squared minus b squared, that's a difference of 2 perfect squares. This factors into a plus b times a minus b. So just something to be mindful of when you are always factoring. So let's go ahead and finalize this as our answer. Moving on to the next problem. So using the factoring technique, we're going to simplify this. So the idea here is to factor the numerator and the denominator, and then try to cancel common factors from top and bottom. So x squared minus 1, so again, that's a difference of 2 perfect squares. That can be factored into, in this case, x plus 1 and x minus 1. And the denominator, again, the coefficient of x squared is 1, so you can sort of look for numbers when you multiply them to give you a -2, adds up to b term, which is 1x. So the numbers are x plus 2 and x minus 1. And you can check that by redistributing the factors. Now we can go ahead and cancel out common factors. So I see this and this will cancel. So we're left with x plus 1 over x plus 2. So I will claim this as our final simplified answer. Another factoring question. Now we're going to be doing division. So if you have division between fractions, you have to multiply by their reciprocal. So you keep the first fraction, you change that to multiplication, and this one you're going to reciprocate. So let's go ahead and do that. So we got x squared plus 2x minus 15 divided by x squared minus 25. Change the division to multiplication and we reciprocate, so flip. So you'll have x plus 5 on top and x plus 2 on the bottom. And now just continue factoring. So x squared plus 2x minus 15. Again, look for two numbers to give you negative 15, adds up to 2. So we put x here and x here. And we're going to get 5 and... So 5 and negative 3 will do the job. Because 5 times negative 3 is 15. When you add them, you get 2. So x minus 5, x plus 5, and x minus 3. Then for the denominator, again, difference of two perfect squares, that factors into x plus 5 and x minus 5. For the second fraction, there is really nothing to do other than just rewriting them. So I'm just going to rewrite and put parentheses around to treat it as a same factor. Now we can cancel. So I can cancel. So here I seem to have extra x. Okay, now it's good. So now if I look for common factors, top and bottom, we can cancel them. So x plus 5 with x plus 5. And then that's really it. There is nothing else that's going to cancel. So it looks like our final simplified answer on the numerator is x minus 3 and x plus 5 all over. On the denominator, we got x minus 5 times x plus 2. So that will be our final answer for this example. So for number 10, we're going to combine these two fractions. Now, this one has denominator x minus 4. This one has denominator x plus 6. You need your least common denominator to be their product. So it'll be x minus 4 times x plus 6. That'll be the least common denominator. So let me go ahead and just rewrite the problem for you so you can see what I'm going to do with the least common denominator that I just found. So what you're going to do, you're going to take your fractions and multiply by what they're missing, top and bottom. So this one is missing x plus 6, so I multiply that top and bottom. And this one is missing x minus 4, so I multiply that top and bottom. And that will be equivalent to 1, so you don't really change the problem. And put parentheses around to protect your terms. And now we can go ahead and combine the numerators. So you got x times x plus 6 from this one right here by combining. And this one minus all of that. So let's rewrite. It'll be minus 3 times x minus 4 all over the same denominator, x plus 6 times x minus 4. Now we got some distributions to do. So here I distribute the x, here I distribute the negative 3. So that gives me x squared plus 6x, and then negative 3x plus 12 all over the same denominator. I always like to keep my denominators factored. If you want, you can expand, but this is really fine. Now look for like terms on the numerator. So I see this is on its own, but these are like terms. So you can kind of combine them. So you got x squared plus 3x plus 12 all over x plus 6 times x minus 4. Now you can try to factor this, but it wouldn't factor. So we can leave it right here. I believe it's not factorable. Okay, let's continue on to the next problem. Here we're going to solve this equation for number 11. Another problem that involves a lot of distribution. So you want to isolate x. So first thing first, distribute. So you can get rid of all the parentheses. So 2 times 1, that's 2. Minus 2 times x, that's 2x. And then 3 times 1 on the right-hand side, that's 3. Plus 3 times 2x, that's 6x. Still got a plus 5. Now just combine like terms. So I can combine the 3 and the 5. So 2 minus 2x is equal to 5 plus 3. That's going to be 8 plus 6x. And then move things around. So I can go ahead and get rid of the 2 and the 8. I can combine them, subtract 2 from both sides. So that leaves you with the negative 2x is equal to 6 plus 6x. And now I can subtract a 6x on both sides. So that leaves me right here. Negative 2x minus 6x, that's negative 8x, is equal to 6. And now I can finally divide by 8 on both sides. Negative 8. So that leaves me with x equals negative 6. A 6 over 8, you can reduce them by 3 over 4, negative. So our final answer will be x equals negative 3 over 4. Your answer should always be in simplified form. So this will be it. Number 12, solving a quadratic. Let's move everything to one side, set it to 0. So we're going to move these to the left by subtracting them. So you'll have x squared minus x minus 12 equal to 0. And now you can either use quadratic formula, completing the square, or factor. So I'm going to go ahead and try to factor this. So here is x, here is x. Now you need two numbers to give you their product to be negative 12, adds up to negative 1. So 4 and 3 will do the job. 4 has to be negative. So you got x minus 4 and x plus 3. So that will work. Now you set each factor to 0. So I got x minus 4 equals 0. And I have x plus 3 equals 0. This gives me x equals 4 by adding 4 to both sides. And this gives me x equals negative 3. So there you have your two solutions to this problem. Number 13, this is a literal equations where you have multiple variables. You're only going to solve for one variable. Here, our goal is to solve for h. So h is trapped right here. Let's isolate. So you need to get rid of all of these pieces from h, so h is isolated. Let's get rid of 1/3 by multiplying both sides by 3. So you got 3v is equal to pi r squared times h. And now these variables are just multiplying h, so I can divide by all of them. So divide by pi r squared on both sides. So I have h totally isolated, 3v over pi r squared. So there you have your final simplified answer. Number 14, we're solving an absolute value equation. So it is best to remember its absolute value inequality. So it is best to remember its definition. So if you have an expression of this form, let's call it that. Now this is written as x is less than c or bigger than negative c. So just like that. So I'm going to break this up. So think of as this is your x, this is your c. So split this up into that form. So we have 2x plus 1 is less than 19, and of course bigger than negative 19. Just like that. So 2x plus 1 is between negative 19 and 19. Now you're going to go ahead and try to isolate x right at the center. So I'm going to subtract 1 on both sides or all sides. Subtract 1, subtract 1, subtract 1. That leaves you with negative 20 is less than x is less than 18. 2x, I'm sorry. And now I divide both sides or all sides by 2. So that gives me my final inequality. Negative 20 divided by 2, that's negative 10, is less than x, is less than 18 over 2, that's 9. Okay, there you go. So this is our solution. You don't have to test x values into this inequality because this is already explicitly stated. So our solution in interval notation, open parentheses, negative 10 to 9, open. Because of the less than or equal to. Having strict inequality, we'll put parentheses. So this will be our final answer. For the next problem, we're going to sketch this piecewise function. So the plane has been split at 2. So that's the interval. When x is less than 2, we have a graph. When it's bigger than or equal to 2, we have another graph. So let's see how it's going to look like. So suppose this is our xy plane. This is your x, this is your y. So when x is less than 2, suppose this is 2. So less than 2 is this direction. So when x is 2, we're at 3. So 2, let's say 3 is here. Open circle because it's strictly less than 2. And then I'm going to go less than 2, that's this direction. So we just have a horizontal line at 3 when x is less than 2. So this is f of x equals 3 when x is less than 2. Now bigger than 2 is this direction. So we have this line right here. So let's plug in 2 so to see where to start the graph. So f of 2 is equal to 1 minus 2. Plugging in x equals 2, that gives me negative 1. So this point, 2 comma negative 1, is going to be a closed point because it's greater or equal to. All right, so let's find that point in our plane. So it's right here. So 2, negative 1, it's going to be just right there. And it's a line that has negative slope. So now if you want to know which way the line is approaching, so pick a number bigger than 2. Let's say 3. Plug it in here. So you got 1 minus 3, that's negative 2. So when x is 3, your y value is negative 2, so it's going to be down here. Then you just connect them this way. Something of this style. So it's a line that's going downward. So I'm just going to retrace it so you can see it. There you have it. So this is our function f of x equals 1 minus x when x is bigger or equal to 2. So that's why we got the close point at this endpoint. So there you have it. Together, they form a piecewise function. Number 16, we're going to find an equation of the line passing through these points. So we need the slope of the line. So the line, I'm going to write it in point slope form. So y minus y1 equals m times x minus x1. We need the slope. So we know the slope is y2 minus y1 over x2 minus x1. Let's label our points. Call this x1, y1. Call this x2, y2. So plug them into our slope formula. You got negative 4 minus 2 over 3 minus negative 1. So very carefully plugging them in. The negative 4 minus 2, that's negative 6. And then 3 minus minus, so this is going to be plus 1, that's 4. So the slope will be negative 3 over 2. So that's what I'm going to plug in right here. And then the point, you can pick either of them, either this or that. Whichever you like, it's fine. So I'm going to use this one because I already label x1, y1, so why not just put them right in here? So our equation of the line would be y minus 2 equals to negative 3 over 2, x minus negative 1, and of course double negative, you can turn that into a plus 1. So this is our equation of the line that passes through these 2 points. All right, let's moving on to the next problem. Now find the domain of this function. Since it's a square root, we want this quantity to be always positive or non-negative. We want this to be bigger or equal to 0. So you can set it like this, 7 minus 3t greater or equal to 0. And now we just solve for t. So let's go ahead and subtract 7 on both sides. That gives us negative t is greater or equal to negative 7. Now we divide by negative 3. So here we're going to switch the direction of our inequality. So we got t is less than or equal to 7 over 3. So in interval notation, we can say, but before that, let's draw it on the real line. So 7 over 3 is right here, less than or equal to, so solid circle and go to the left. So in interval notation, we got negative infinity all the way to 7 over 3 bracket is our domain. So this is the domain of G. Number 18, we're going to find the net change of this function between x equals 1 to x equals 1 plus h. So net change, you have to know this formula. This is f of b minus f of a. That's the net change. So let's call this value our a. This is our b. So this entire 1 plus h is our b. So let's find them. So f of a is going to be f of 1. Plug in 1 into function. So you're plugging in 1 into this x in the function. So you got 3 times 1 squared plus 2. That'll be 3 plus 2. That's 5. And then f of b would be f of 1 plus h. So that'll be 3 times 1 plus h squared plus 2. Again, I'm inserting 1 plus h in place of x in the function. So then 1 plus h, you have to expand that. So it'll be 3 times 1 plus h when you expand. That's really 1 plus h times 1 plus h, just like that. So you distribute. You got 1 plus 2h plus h squared plus 2. Here we distribute the 3 out. So we got 3 plus 6h plus 3h squared plus 2. And now I can combine like terms, 3 and the 2, that's 5. So we got 5 plus 6h plus 3h squared. So I got my f of a, which is 5, f of b, that's this right here. So we subtract them now. So the net change, it's going to be the f of b value minus f of a. So that'll be 5 plus 6h plus 3h squared minus f of a, that would be 5. And now you can drop the parentheses since it's just one term, and you'll see that this 5 and negative 5 cancels. So you are left with just 6h plus 3h squared. So that will be your net change of this function. Now for number 19, we're going to be using this graph. So as you can see it here, so you can avoid all of this work. That was for number 18. Number 19, we're going to look at this graph right here to analyze. So we're going to look at the range of that graph. So the range will start from the lowest y value, that's right here, which is -1, including it. And we're going to go all the way up to the highest value because the graph exists left to right. So the highest value we see is 1, 2, 3. It's scaled by 1. So we want -1, 2, 3. So that will be the range of this graph. And they're both included. Now for number 20, that's the last problem of this exam. We're going to sketch this and label all intercepts. So you could make table of values, but I'm going to use transformations to graph this. So this right here, it means it's a reflection over the x-axis. And then this +1 inside the parentheses represents a horizontal shift. So we're going to go left 1 unit. So if you haven't learned transformations, you might want to make table of values, come up with a sketch, find the x and y intercepts, or you can do transformations that I'm showing you right now. So we're going to start with the graph. So our basic graph or basic function is going to be x squared. And now I'm going to apply transformations on this basic graph x squared. So here's my xy plane. So x squared, by now, we all know how it looks like. It's a parabola that's facing up just like that. This is x squared. And we're going to reflect over the x-axis, so it's going to look like this. So again, do your best when it comes to sketching. It passes through the point 0, 0. So this is the graph of -x squared. And then x plus 1 squared, that's just going to go left 1 unit. So let's call that. And then you just make the same shape. So I'm going to go ahead and erase this so it doesn't overcrowd our picture. So it's going to look like that. So let's try to draw it again so that it looks nice. There we have it. This is -x plus 1 squared. That's your y. And now we're going to label the intercept. So one intercept is right here. It's already there from transformation. Now the y-intercept is right here. So for the y-intercept, I'm going to set x equal to 0. So you got y equals -0 plus 1 squared. So I'm plugging in 0 into the original. So this will give me -1 squared, -1. It's a little bit off scale, but let's suppose that's -1. All right, so that completes our graph and that completes the test. So I hope you have learned something and being able to check your answers with my work. I will see you next time. Take care.